The control system form. In this lesson, we will introduce you to the control system form. Before we look at the subevent in SMIS, let's take a look at the subevent definition to understand what should be entered on this subevent, including who should enter it. To do this, we will need to head to the RSSB service desk. We are now in the solutions area of the RSSB service desk. You can see at the top of the page here in Home Solutions, SMIS definitions, SMIS sub-events. We are in the control system sub-event definition page. So firstly, here we can see the control system definition, which is any brake demands generated by a train track control system or failures of a train track control system. Systems include automatic train protection, so ATP, automatic warning systems, AWS, driver safety device, DSD, European train control system, ETCS, guard, indice, mechanical train stop or tripcock, tilt authorization and speed supervision, TAS, train protection and warning system, TPWS, and track circuit actuators. Next we have SMIS reporting scope, which is an excerpt from Table B of the SMIS application matrix. So the SMIS reporting scope includes two main event categories for control systems. The first is failures of the train track control system. So that's any case of a failure of one of the previously listed, it's repeated here, control systems. So these events are to be input by the infrastructure manager, except for the failure of on-train equipment only, which should be reported by the railway undertaking. If the latter, there's a guidance note here as well to say that a prior sub-event of train fault will need to be added to the control system form in this instance. The second type of event category are interventions and activations of track train control systems on a train that is not the result of a failure of such a system, so not the same as these ones. So again, it's any brake demand initiated by this repeated list of SIS train control systems. So these events are to be entered in SMIS by the railway undertaking. Next, we have some examples of what's included in this category. So technical failures of the control system, failures in the control system software, incidents of the control system correctly generating a brake demand, and incidents of the control system incorrectly generating a brake demand. Also incidents of the system failing to generate a brake demand, and then tripcock activations. In terms of exclusions from this sub-event form, an exclusion is the signal passed at danger or SPAD event. So that's when a control system occurs in conjunction with a signal passed at danger event. The reason for this is because there is a separate control system section present on the SPADs and railway operating incident form, meaning that you don't need to add a separate control system sub-event form. On that note, there are two other forms that are part of the simplification, which also have a control system section on the main form, and these are the train failure form and the infrastructure failure and irregular signal aspect form. For control systems that occur in conjunction with one of these sub-events, the control system can just be added to one of these forms instead of having to add a separate sub-event. And then finally, we have event scenarios. So this details some of the common SMIS scenarios that you would record under this event category and includes details relating to which prior sub-event you need to add and or which objects and object roles are applicable to the scenario. Now that we understand what should be entered into SMIS on the control system form, let's take a look at the form in SMIS. So we now have opened the control system form, and let's head over to the location section. So remember, we're just looking at the location section on the control system form. For all control system events, you would either select the location type as running line or yard depot siding, as the location type is based on where the train was at the time of the event. Once you choose the correct location type, you are then presented with more granular location information in the form with follow-on questions. But we have a separate video which covers entering locations in SMIS for further information on this. Let's look at the main sub-event section for the control system form. You can see immediately the red bar or object guidance that appears to the right to remind you about adding objects to this type of event, which in relation to control systems would be the train object, but I'll cover this in the people, trains and objects section of the video. The first question, which is on the form, is did the driver inform the signaller of the event? In this case, let's say yes, they did. In the main control system section, you can see that the section repeater is already present on the form, and this is where on the right hand side you can add what type of track train control system was involved in the incident. If you remember, we went through the list of control systems applicable on the sub-event guidance page of the RSSB service desk. So this same list of control systems is replicated here. Depending on the control system that you select, the questions within the section will be tailored to that particular system. For this example, let's take the scenario. The driver of a train had a train protection and warning system, TPWS, overspeed activation approaching a 60 mph permanent speed restriction. Let's go ahead and add the train protection and warning system via the section repeater. You will now be asked some specific questions tailored to TPWS. So the first question is, did TPWS generate a brake demand? So in this scenario, yes, it did. After selecting yes, we're then asked, was the TPWS brake demand after the driver had applied the brakes? So in this example, let's say yes, it was. Answering this question as yes or no determines whether it is deemed as an activation, which in this case it is, or an intervention when extracting the data using Jaspersoft. Next, we're asked what speed was the train travelling at when it passed over the TPWS loop. So let's say it was travelling at 65. Next, you get to specify the measurement of units, so I'll say it's in miles per hour. The following question is, did the driver reset TPWS and continue without authority from the signaller? In this case, they didn't, so we'll select no. Then we have, should a brake demand have been generated by TPWS? In this instance, yes, it should. This means that the system was working as intended. The next question is, what type of TPWS loop was involved? So in this example, it was an overspeed sensor system, so OSS. After answering that it was an overspeed sensor system, you then get the question, what is the OSS protecting an approach to? In this example, It was protecting the approach to a speed restriction. When selecting speed restriction, you're then asked, what was the speed restriction type? And in our example, it was a permanent speed restriction. The next question is, what is the set speed of the OSS loop? And from our example, if you can remember, it was 60 miles per hour. Staying within the sub-event section, we'll move down to prior sub-events here, where you get to add just one prior event if it led to the main control system event. Prior sub-events that are available on the control system form include, so select yes, you get the section repeated to add a prior sub-event, and here we can see the list of options available. So we have another control system, so say when a train experiences two control system activations, one after the other. Also, the railway infrastructure fault can be added as a prior event, say for a train having an AWS code 2 at a signal due to a cut cable, which was a result of vandalism. So you'd add the railway infrastructure fault as a prior. We also have railway operating incident that you can add as a prior. So that would be something like a train driver speeding and then receiving a brake demand as a result of that. Then you can also add a train fault as a prior event. So that's say if the train fault was the cause of the brake application. And then we have finally train striking or being struck by an animal, object or road vehicle. That's say if the train receives a brake application due to striking a dead animal on the track. So they're the prior sub-events that you can add to the control system. Now we will look at the people, trains and other objects section in relation to the control system event, where I am going to point out some of the more common objects and object roles that you would be expected to record in relation to this type of event. As a reminder, there is only one people, trains and other objects section on each SMIS form, meaning that if a prior event is involved, this is the section where you would add any object that are involved in both the prior event if they are different than those involved in the main. So the main event objects also get added here. So for control systems, you would always add the train object. So I will go to add all involved people, trains and other objects, go to the right hand side and select a train. In terms of what role the train plays in these types of events, there is a role called involved in a train track control application or fault, so you can select that. Just as a reminder though, you select as many roles as are applicable. So say for example, if like previously was mentioned, the train was also speeding at the time, so had a prior sub-event of railway operating incident, you can also select the role for the train of involved in an operational incident. There are other fields that you can enter under the train object, but we have a different video on entering people, trains and objects that you can refer to for more information on what to enter for train objects. On the topic of the train speeding prior sub-event, if you were to add that, at this point you would also want to add a person object for the prior railway operating incident event. So I would go ahead then and add the person for the prior event here. And again, you would need to go through all the roles that the person played to select the appropriate ones. And for this one, If it was the driver speeding, you would say was involved in an operational incident. And driver of a vehicle. And again, for person, there are other follow-on fields that you can select and enter, but like I said, we have a separate video on people, trains, and other objects, which will go through these fields. Finally, let's go through some of the relevant possible causes for the control system sub-event. So if we go to the possible causes section, one of the first ones is cause unknown, where if following the investigation into the incident, it is not apparent what caused the event. So you can select cause not known. If, however, the cause was due to driver error, then you have the following causes. So you go to human performance factors, railway operational activities, driving trains, and here you have a long list of options to select from, including the option did not operate brake effectively. So this is where you go if the cause relates to driver error. If instead, though, the cause was due to the failure of the system, whether it was on train equipment or trackside equipment, you then go to infrastructure, vehicles, equipment, and clothing. If we are saying that the system fault was with the vehicle, you go to vehicle, you can then select unreliable, faulty, or not working, and you can select one of the options from the rail vehicle fault. If instead the equipment failure was with the line side equipment, then you would go again to infrastructure, vehicles, equipment, and clothing. You would alternatively select the railway infrastructure, and you would select unreliable, faulty, or not working. And you would select one of the options from here to say that the infrastructure was faulty.